Today we're going to talk about circles and their equations. The first thing I want to mention about a circle is just a definition. Mainly that a circle is the set of all points equidistant from a fixed point called the center. Now, the center is not actually a point on the circle. The circle is the outer edge. It's all the points that are this equidistance from the center. Okay, and so we all have a feeling for what a circle looks like. That's not too bad. And so it's all points whose distance from the center is fixed. Now, generally, we would call that distance the radius r. Okay. Now, if I were to have a central point, let's say, for instance, that it's right at the origin. Okay. So that central point is at the origin, which means I have a y-axis running vertically here, and an x-axis running horizontally. And then let's say, for instance, that a point on the circle, we'll call it point P. I'm going to give it the coordinates x comma y, and the center I'm going to call it C. So C is the center at the origin, 0, 0. P is a variable point, x, y. It could be really any of these points around the circle. What I know is that the distance from C to P, or P to C, however you want to represent that distance is fixed. It's the r value, okay? So the distance from C to P is equal to the radius. That we know. But in addition to that, the distance is found using the distance formula. If you'll recall, the distance formula is derived from the Pythagorean Theorem. It is the square root of the sum of the squares of the horizontal and the vertical sides of that corresponding triangle that exists between the 2 points. And so to find that hypotenuse, the longer of the sides in the Pythagorean theorem, you take the square root of the sum of the 2 squares. You take the x distance squared and the y distance squared, add them together. Now the x distance is just the difference between the 2 x coordinates, which in this case is x minus 0, and you square that. The y distance is the difference in the y coordinates, which would be y minus 0, and you square that and add those 2 squares together. Now, of course, that equals the r on the other side. Now, if I want to simplify this equation, x minus 0 is just x, y minus 0 is just y, so this could be seen as the square root of x squared plus y squared equal to r. And then, to make this look even nicer, if I square both sides of the equation, I get x squared plus y squared is equal to r squared. This is the general form of any circle centered at the origin with a radius of r, okay? Specifically centered at the origin. So, circle of radius r centered at the origin. It is a nice equation. It just has a bunch of squares in it. Now, if that circle, now I can expand it, I can shrink it, and the radius then just gets plugged in and squared on the one side of the equation. If that circle then is shifted, I could shift it left or right. It'd be right or left to you guys. That would be up or down. I can actually adjust the x and y coordinates. So now let's say for a moment that my circle is not centered at the origin, that it is instead centered at the point h comma k. All right, so I've shifted it over h units horizontally and k units vertically. Okay, so I have a new central point. Well, the arbitrary points on the circumference there, I'll call them P, still have the coordinates x, y, they're variables. The center is at hk. If I recreate this formula now using hk as my central point, then the distances are going to be x minus h and y minus k squared respectively. Those are the distances between, the horizontal and the vertical distances. So horizontally you're looking at the difference between x and h, which is x minus h, and vertically we're looking at the distance between y and k, which is y minus k. All right. That changes this formula slightly. When you square both sides, you end up with the formula x minus h squared plus y minus k squared equals r squared. This is the equation for a circle centered at the point hk. Centered at hk. Again with radius r, same radius. Okay. You can see the shift take place within the x. It's a shift of h horizontally and a shift of k vertically in the y there. Okay, so that corresponds to our our horizontal and vertical shifting. Okay, now with those two formulas, and this one is the more general one. Of course, if the origin is our center, we just plug in the zeros for h and k, and that gives us just the x squared and the y squared. And so if I want to plot the graph based upon an equation, so if I had, here's the equation, x minus 3 quantity squared plus y plus 4 quantity squared equals, let's go with 16, then all I have to do is really pick out the center and the radius to get my circle, okay? So I know from this that the center is at 3 comma negative 4. It does need to be the opposite sign of what's in here, right? If this is x minus h, then the h is 3. If this is y minus k, then you need a negative value on the k to get the double negative to make a positive. So you do need the opposite sign there. So 3 comma negative 4 is the center, and the radius is this number here is going to be r squared, which means the radius would have to be 4. It's the square root of whatever that number is. Okay. So I could then plot that point, or plot that circle. If I were to center that at 3 comma negative 4, I go over 3 to the right, down 4. And then I need a radius of 4. So my radius, so going vertically from this 3 negative 4, that would go up to the x-axis. That would go over here. Let's see, 3 gets me back to the y-axis, so I need to go one more unit over. I could go down 4 units. That would put me at negative 8. And I'm just drawing these kind of rough, right? That's just a rough sketch of where they would be. Rather than plotting all the details there. And then over that way, 4 more units would put me at 7, negative 4. So my 4 sort of cardinal directions, north, south, east, west points are going to be 7 comma negative 4. Here it's 3 comma negative 8. Here it's 3 comma 0. And here it is negative 1 comma negative 4. So that gives me 4 units in each direction for the radius, and then I can connect those with as good of a circle as I can draw. It's a little bit egg-shaped, but it works, okay? Not too bad. So there's my circle. Found the center, found the radius, got the graph. That will work. And of course, if I knew the graph, I could come up with the equation of the circle pretty quickly as well. So if I had a graph, it was, let's say, oops, let's draw the circle first. And let's put that circle maybe down here. Let's put that at -3, -2 maybe. It's in the third quadrant. And let's give that a radius. Let's say that's a radius of 5. So a radius of 5 on that. And so all I really need to do is go to my formula, plug in the h and k values, and then square the 5 and plug it in for the r squared. So we would have x plus 3. Remember, you change the sign because it's x minus h minus the -3 would be x plus 3, plus y plus 2 squared. Again, the change the sign on the 2, and then we square the 5, put the 25 in on the other side. That would give us the equation of that circle. Okay. Now the other thing that's kind of interesting when we deal with circles is if the equation is given but it's all expanded out and we don't have these nice, neat, perfect square terms. One thing you do need to recall in order to work with those is how to complete the square, particularly the idea of the perfect square trinomial. You may or may not recall this immediately, but if you have a binomial squared, 2 terms squared, we cannot distribute the square. Instead, we expand, use the distributive property to make sure every term on the left multiplies every term on the right, and what you eventually end up with, I'll skip a step here or two, you get a squared plus 2ab plus b squared. Okay, and so some simple examples of this, you have to have squares on the ends and double the product of the square roots in the middle. Some examples, x squared plus 6x plus 9. You can see the squares on the ends, perfect squares, double the product of their square root, right? So this is x squared, 3 squared. This is 2 times the x times the 3 in the middle. And so this is what we call a perfect square trinomial. Its factored form is simply x plus 3 squared. It's the 2 square roots added together and then squared. This becomes very useful. Obviously, the perfect or the factored form, the square form, shows up in these equations for the circle. And so if the equation is all expanded out in this form, we can get it back using the completing the square technique that you may have learned hopefully in an algebra class somewhere along the line. Give you an example. If I had the equation x squared plus y squared plus 4x, let's go minus 6y, I don't know, plus 3 equals 0. I don't know, I'm making this up on the fly, right? So what I want to do is I want to get this equation into the form, where do I want to put this? I'll put it up here. We don't need the definition. So into the form x minus h squared plus y minus k squared equals r squared. We want to get it in that form. Again, I want to complete the square. So I'm going to group together the x terms, group together the y terms, get any constants over on the other side. So I'll start with the constant, subtract that over. Now I'm going to group together my x's, but I've only got 2 of the terms, right? In the perfect square trinomial, I've got the a term and the 2ab. I'm missing the b squared term. So I'm going to hold off and leave a little space. Then I've got to get the y terms together. So I have a y squared minus 6y. Again, I'm going to leave a little space for the constant term, and that's going to equal a negative 3. Okay? So what I need to do is figure out what that constant is going to be. The trick to doing that, to figure out what b is you take the middle term and divide by the 2. That will free up the b, because the a is already the x essentially. So if I divide this by 2, I'm going to get 2, right? So 4 divided by 2, I like to write it out this way. If I chop that in half, I get 2, and then that's my b value, and then to square that, I get 4. So raise that to the second. That would be adding a 4 to the left side. But if I add a 4 to the left side, I better add a 4 to the right side as well. Otherwise, I'm violating a principle of equality, right? Whatever I do to one side, I better do to the other one. Then for the y value, similar idea. I'm going to chop this middle term in half, divide by 2, that gives me a negative 3, and then square that. So I'm going to raise that to the second power, and negative 3 squared is going to be a 9, so I'm going to add 9. But I can't just, again, add 9 to the left, I better add 9 to the right as well. So I'll do that, add the 9, okay? Okay, so I've added the same amount to both sides. Essentially, I've added a 13 to the left and a 13 to the right in total. Now when I factor these, the first 3 terms match the perfect square trinomial formula, so I factor them into a sum squared, and it's the a plus b, which are the square roots, so it's x plus 2 all squared. With the y's, it's going to be y minus 3 all squared. It's going to be that b value coming down. Okay. On the other side, when I combine my terms, negative 3 and 4 is 1. 1 and 9 makes 10. So I get a 10 there. And so that is the final form of the equation. What it tells me is that the center of this circle is at the point negative 2 comma positive 3, again switching the signs or changing the signs of both of them, and the radius is the square root of 10, right? Because 10 is r squared, so you take the square root to get the radius. So that gives me all the information I really need in order to plot the graph of that circle.